So in this example, we want to graph f of x equals 2x plus 3 over x minus 1. Now, as we've seen when we've graphed other kinds of functions, we want to begin by kind of finding the key features of the function. And the key features of a rational function are the asymptotes. So we want to start by finding any asymptotes that we have, both vertical and horizontal asymptotes. So the first thing that I look at is, are there any common factors in the numerator and denominator? And in this case, there are not. 2x plus 3 can't factor, x minus 1 can't factor, so there's nothing that they have in common. So if we look at the vertical asymptotes, we do that by looking at the denominator and seeing what causes the denominator to equal 0. So if we take x minus 1, set that equal to 0, and solve, add 1 to both sides, x is going to equal 1. So we're going to have a vertical asymptote of x equals 1. So that's going to be a key feature that we're going to want to see in our graph. So if I come over here, here's 1. I'm going to draw a vertical line through x equals 1. And that is x equals 1, and that's again that vertical line that's crossing the x-axis at 1. Now I draw that as a dotted line because the vertical asymptote isn't really part of the graph, it's just there for reference. Now what about horizontal asymptotes? Well, I look at the degree of the numerator and the degree of the denominator. Notice that the degree of the numerator is 1 and the degree of the denominator is 1. So the horizontal asymptote is going to be the leading coefficient of the numerator divided by the leading coefficient of the denominator. So it's going to be a horizontal line, y equals, the leading coefficient of the numerator is 2, the leading coefficient of the denominator is understood to be 1, and 2 divided by 1 is 2. So our horizontal asymptote is the horizontal line, y equals 2. That's another key feature of this graph. So here's 1, here's 2, and so I'm going to have a horizontal line that goes through 2 on the y-axis, and that is our horizontal asymptote. So I know now, because of my vertical and horizontal asymptotes, I have an idea of what this is going to look like. It's going to be like, maybe the graph's going to be here and curve up, so it's going to be asymptotic to both the y equals 2 and the x equals 1. So it could be that it curves up like this, or it could be that it curves down like this. And then the same on the other side. It could be that it curves like this, or it could be that it curves like this. I just have to find a couple of points in order to kind of have an idea of what that's going to look like. So I generally like to find a couple of points on either side of the vertical asymptotes. So I'm just going to make a table of values for x and y. So for example, if I start to the left of the vertical asymptote, maybe I'll let x equal 0. If I let x equal 0, then f of 0 is going to be 2 times 0 plus 3 over 0 minus 1, substituting 0 in. Well, 2 times 0 is 0, plus 3 is 3, and 0 minus 1 is negative 1, and 3 divided by negative 1 is negative 3. So I'm going to have the point 0, negative 3, which is right there. That's our y-intercept. Now, maybe find another value. Perhaps we'll let x be negative 1. So if I find f of negative 1, that'll be 2 times negative 1 plus 3 over negative 1 minus 1. Well, 2 times negative 1 is negative 2, plus 3 is 1, and negative 1 minus 1 is negative 2. 1 divided by negative 2 is negative 1/2. So I have the point negative 1, negative 1/2, which would be right here. So our graph is going through those 2 points, and it's going to get asymptotic vertically to the line x equals 1, and it's going to get asymptotic horizontally to the line y equals 2. So this graph is going to be coming around something like this, going through this point, going through this point, going down, and getting asymptotic to this vertical line x equals 1. So over here to the left of the vertical asymptote, the graph is going to look something like this. Now let's check to see what the graph is going to look like to the right of the vertical asymptote. So I'm going to substitute in maybe the values 2 and 3 and see what's happening. So if I let x equal 2, then f of 2 is going to equal 2 times 2 plus 3 over 2 minus 1. Well, 2 times 2 is 4, 4 plus 3 is 7. 2 minus 1 is 1, and 7 over 1 is just 7. So I'm going to have the point 2, 7. So here's 3, 4, 5, 6, 7. So the point 2, 7 is going to be around there. If I substitute in 3, well, f of 3 is going to be 2 times 3 plus 3 over 3 minus 1. Well, 2 times 3 is 6. 6 plus 3 is 9, so 9 over 3 minus 1 is 2. So I have the point 3 9/2. Now 9/2 is the same as 4 1/2. So here's 2, 3, 4 1/2 would be around here. So 3 9/2 would be around that point there. So this graph is going through these 2 points, and then it's going to curve and get asymptotic to this line y equals 2. And as I go to the left, let me extend my vertical asymptote, it's going to curve and get asymptotic to that line x equals 1. So our graph is going to look something like this. Now if I bring back in my calculator, I can put in 2x plus 3 in parentheses divided by parentheses x minus 1 and graph that, and I can see that it does in fact look the same as my hand-drawn graph. In fact, if I draw the y equals 2, we can see that we are approaching that horizontal asymptote. So notation-wise, I can say that as x is going to negative infinity, f of x is going to 2. So as I'm going this way, the values of y, the function values, are getting closer and closer to 2. I can say that as x goes to positive infinity, f of x is going to 2. So as x is going this direction, the y values are getting closer and closer to 2. So that describes the horizontal asymptote. Now something we haven't done previously is to describe the vertical asymptotes. So the vertical asymptote is x equals 1. Well, I do that this way. I say as x goes to 1, and I'm going to look at that from both sides of 1. So if I'm on the left side of 1, I'm going to indicate that with a negative sign that's kind of superscripted up behind the 1. So this is saying as x approaches 1 from the left. That negative sign means from the left, to the left of it. And as x approaches 1 from the right, then that I'm going to indicate with a superscripted plus sign behind it. So this is x approaches 1 from the left, x approaches 1 from the right. Well, as x is approaching 1 from the left, the y values are going to negative infinity. So I'm going to say f of x goes to negative infinity. And over here, as we're approaching 1 from the right, f of x goes to positive infinity. So this describes horizontal asymptotes. This describes vertical asymptotes. So a vertical asymptote, as we're approaching a number, we're either going to go to negative infinity or positive infinity. And whereas with the horizontal asymptotes, x is going to negative infinity or positive infinity, and then the y values are approaching a particular value. So here we've graphed our function f of x equals 2x plus 3 over x minus 1.